Hello everyone, so today we're doing 2D displacement mapping. So I'm starting with, this is what you get basically when you get out of the texture maker. So you've got a albedo, a displacement, a roughness, and a normal map. I'll show you how to set those up. So the first thing that I'm doing is I'm just going through and unzipping them all. Go through this quickly. But yeah, so basically albedo is your color, normal is direction, roughness is the amount of reflection, and then the displacement is lift, how far up or back the texture goes. So first things first, we're going to start with is just a plane. And then we've got to put an edit mesh modifier on it. And see those lines when it's in the wireframe view, and we also need to make sure there's far more of those, because so that's with the turbo smooth, because that is the amount of, it's like the resolution, pixels basically, which makes a lot of sense now that it's in 2D. This is called the Slate material editor. I prefer it. You have a bit more control over your textures. I'm wondering why can't the V-Ray thing comes up. This is actually an important thing. You need to make sure that your renderer is set to V-Ray, which you do up there. And we'll go through a couple of the V-Ray settings. So yeah, make sure it's V-Ray GPU or CPU. And make sure it's iterative rendering for this. Make it kind of a small thing. Make sure that displacement is on. And yeah, there should be a few other settings that I'm kind of pointing to. Make sure that it's looking like mine is. And yeah, I'm going to turn off the V-Ray displacement modifier, like the V-Ray displacement as the default, because we're going to do some physical displacement first, just to show you how that works. It's basically just two different systems. V-Ray has it built in, so you don't need to use a turbo smooth to subdivide your surface. But yeah, and they seem to work about the same. It doesn't seem to save you much computing power. The thing to remember though is do not have them on at the same time. I do that halfway through this video and there is a crash, because then it's subdividing something millions of times. Subdividing something very small. Yeah, and so basically they use edge lengths, which is the same idea. 4 is standard. Okay, so first thing first, pick a couple of your V-Ray bitmaps. Just put them all down. So yeah, that's the displacement at the end. Most of them pretty straightforward, but with the normal map, you do need there's just a V-Ray normal map little box, and that just converts the information, which is the kind of direction that the displacement should go, into something that the V-Ray material can read. So put the albedo onto the albedo, and then the roughness onto, that's a third one down. I can't read it right now, but you can probably read it because your screen is bigger. But and then yeah, the displacement onto the displacement. Something about reflection, the roughness one. So yeah, we'll see how this looks. And I'm just showing you a couple of the other ways. You could also just use the displace modifier and then put the displacement map on that way. That's if you're using the standard Slate editor. I'm just going to do both because it makes no difference. And yeah, and then we'll run the V-Ray and we'll see what we get. And oh my god, it's pitch black because there's no light. So I will chuck on a light, and there we go. We'll start to see something once I make it a bit stronger. There we are. So you can see how that's working. You're starting to get some real depth, and the pipes are all coming together. I'm going to turn on a directional light so we get a bit of shadow so we can see what's going on a little bit better. Just a moment. But yeah, you can see that it's really kind of there. There's some stretching, of course, but for backgrounds, for 90% of renders, like exterior renders, you could use this for terrain. You could do a series of planes and making like cubes, and then make facades with it. So yeah, it could be really useful for some uh, rendering techniques, particularly using the 2D, because the 2D, yeah, and we can see when we go on the side the kind of depth that we're getting. But for the 2D displacement map, there's not that heavy on computing power. See, now we're understanding a little bit better how it's working. If yours looks all messed up, just put another iteration on the subdivision if it's not looking good enough. If you do this too many times, probably crash your computer. But yeah, I'm going to show you another one. This is like a speed this way up, but I'll like explain what's going on. I changed all changed all the bitmaps, but because they all have the same name coming out of the renderer that I was using, the AI, 3ds Max couldn't really understand it, so I had to go through and rename each of the bitmaps to then replace it. That was also a thing I learned when I had a whole lot of them in one file, is that, yeah, you should individually name each set so that the pathways all work, otherwise you'll end up with everything all mixed around. So yeah, I'm going to show you what it looks like in 2D. I think I raced through this next one because it doesn't work. I just wanted to see what the kind of more, yeah, this one with more gaps, but it didn't really do anything. So then I replace it with something that has a little bit better displacement. So there we go, put them all in. See, this is what I'm talking about. It didn't really understand. Tried to make a new one. Still didn't work. Do it again. But I realize I've got to rename them. That's the problem. So it doesn't really matter what you name them all individually. You can just name the folder that they're in. But there we go. And this has got a really good high quality displacement map. And yeah, because we've turned off the V-Ray displacer, the physical displacement is all we have there. So yeah, that's how you do 2D displacement mapping.